So, hello everyone. Let us now start our solving. But before that, let us see whether my live is running or not. Let me make sure that. So, wait a second. Right, okay. My live is running properly. So, firstly, let me start with what is today's lead code problem. Lead code, right? So, I have already solved it. Count square submatrices. Just now, I have solved it. Right, so it's nothing but a simple at 5:30 a.m. I have solved it. It's nothing but a simple square count squares of matrices with all ones. I have already solved it before on October 27, 2024. Right, so let us look at the question first. Given m by n matrix of ones and zeros, return how many square submatrices have all ones. Let us take an example: 0 triple 1 double 1 double 1 0 triple 1. Right, so I have given with square submatrix I need to count square submatrices. I'm given with 0 triple 1 double 1 double 1 and 0 triple 1. Right, so if you see clearly, let us just count how many submatrices I got. So I'm counting with a green pen, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What are all these submatrices? They are nothing but with the size of 1. So with the size of 1, nothing but 1 by 1, I have 10 submatrices. Let us count with 2. I can also get with 2, right? So is this a square submatrices with 2 by 2? Everything is 1. No, here I got a 0. So it is not a square submatrix which I am looking for. So I have double 1, double 1, right? So first thing I have double 1, double 1. Now I have first for a 2 by 2 submatrix, I got one submatrix which is having 2 by 2 ones, right? So 1, the count is just 1. Now I'm having this, right? So let me just go let me just go to the next submatrix which I can get is double 1 double 1. Now I'm just incrementing the count, right? So the count is incremented. Sorry, right? So the count is just incremented. Now I have double 1 0 1. Now I have a 0. I don't consider it. Why? Because I need all ones, right? I need all ones, so I don't consider it. Now let's go to the next submatrix here. It is having all ones, so add to the 2 by 2, right? Now I have 1 1 1 1. Everyone in the submatrix, everything is 1, every element is 1, so increment the count to 1. Now I need to count whether there is a 3 by 3 submatrix with all ones. Now, is this a 3 by 3 submatrix with all ones? No, here I have zeros. Now, this is having 3 by 3 submatrix. So here 1. 10 plus 4 plus 1 is 15. Right. Sorry for the disturbance. Right. Now I have 15 submatrix. Right. So there is something which is clear. When I have a 1, I need to add it to the answer. Let me write the intuition for you. Intuition is, if I have a 1, I will add that to the answer. Only one. Only one. Now I have this 2 by 2 submatrix. How do I know whether I have this or not? Now if you see 1 1 1, right? No need to go to the second example even. We can solve this by just using the first example, right? 1 1 1. Now here if I have a 1, then What I am saying to you is 0 triple 1 0 1. Now for this element I have a 1 here, I have a 1 here, I have a 1 here. What I'll do is, if I have the left right sorry, left top and top left, right, left top and top left, if these three are 1, I will add, if it is 1, then I will add the minimum of these three. I'll tell you why I am adding the minimum of these three. I'll tell you in the next iteration. So if I add that, then I would get a 2 here. Now till now, just guess what will be the answer, right? I want you to answer this. What will be the answer till here? I'm not including it. So what will be the answer till there? So 1, 1, 1, and there is, here it is also a 1, right? So sorry for this mistake. So here also I have a 1, right? So I have 1, 1, 1, 1 and a 1. So totally the answer will be 5, right? But when I add this 2, I'll get 7. Why? Because if you see till here, I'm just counting till here. I got 1, 2, 3, 4, 5, 6. 6 1 by 1 matrices, right? Now, there is another matrix, right? I just said 7, right? There is another matrix, which is nothing but this 2 by 2 matrix. So 1 by 1 matrix totally are 6 and 2 by 2 matrix is 1. So totally there is a count of 7, right? So uh, wait a second. I have 2 here, right? Now I just skip this 1. I'll just make it with this one, right? So don't be worried about that. Now when I have at this 1, I have a 1 here. Now I said I'll add the minimum 1, 1, 2, and the minimum of 1 comma 1 comma 2 will be 1, of course, and 1 plus 1 will be 2. Now I just add this 2 to the answer. Let us see whether I am right or wrong. Now, is there any confusion, right? I have till here I said I have 7. How do I said it? How I said it? 1, 1, 1, 1, 1, 1, totally 6, and this is 2 by 2 matrix, totally 7, right? Now when I come to this 1, I have, when I come to this one will be added and if I have 1 here and also a 1 here and also a 1 here, I'll add a 2 by 2 matrix. So if this matrix and this matrix is added, then there will be totally 2. So if I add 2 to the 7, I got 9, right? Now let us go to this 0. Do I have left? No. So don't worry about that. Now let's come here. 1. I got a 1 here. But top left, top left, 1, 1, 0. Minimum of 1 comma 1 comma 0. If you see, the minimum will be 0, and 0, I just I just adding it to the value here, even only if it is a 1. So 0 plus 1 is just 1. Now here comes the actual question. When I am at this 1, I'll check top left and top left, are these all? I just take the minimum out of it, 1 comma 1 comma 1. The minimum is 1. Now this minimum of these three, let me mark it with a red pen, red color. So minimum of these three things is added to this thing. So minimum of these three things is 1 plus 1 is 2. By the way, till here I have counted 9. Then I came here, nothing but it is a 0. Here I have 1. So 9 plus 1 will be 10. I just changing the matrix and every time adding matrix of ij to answer. So I got a 2 here. So 10 plus 2 will be 12. Right? I think till now you are clear. Now let me just erase all these things. It might take a time, but let's be patient, right? So yes, it is clear now. So for this one, I need to get to this one, right? For this one, I'm not checking this matrix, right? Here is what we get a confusion. I'm not checking this one. Instead, I am checking here. I said matrix, right? There will be an important point. Matrix will be changed, and every time after changing it, how I am changing? I'm just adding matrix of ij plus is equal to minimum of this 1 1 1 or top left and top left. So this is how I am changing, right? I am just adding the minimum of top left and top left to the matrix ij, right? So the matrix will be changed. Now I need to check here top left and top left. The minimum of 2 comma 2 comma 2, wait a second, 2 comma 2 comma 2 will be 2, right? So if I add 2 to the 1, then I would get 3. This is why DP, or let me say this as a top down approach. We are filling from the top, right? So 12 plus 3 will be 15. So what I just did, I created from I is equal to 0 to, let me say, the rows are m, and I just went from j is equal to 0 and less than n, m by n matrix, right? Now if you see, when I just started this looking at top left and top left when I have I and j greater than 0. Why? Can you look up here? Can you is there any element which is top to this element? No. To this, no. To this, no. Is there any element top to this element or left to this element? No. Top left to this element? No. For this also, top left? No. For this also, top left? No. No. For this, I have a top, but I doesn't have a top left and top left. For this too, I have a top, but I doesn't have a left and top left. So when I'll check for left and top left and top right, so when I have matrix of ij is equal to 1 and I have I greater than 0 and j is also greater than 0, then what I'll do, that's it. Matrix of ij is equal to minimum of top left and top left. I'll tell you how to write this top left and top left. Matrix of I j plus is equal to minimum of top. How do I write this? Uh, how do I write this top left and top left? Let us imagine we are at in a matrix and I am having 1 1 1 1. Now I am at this point, which is nothing but 1 comma 1, right? Now what is the top here? Sorry, I have cold. I'm suffering with cold, so sorry for this, right? So 0 1 0 1. The row is 0 and the column is 1, which is nothing but top. It is nothing but it is I and j. It is I minus 1 j, right? What is left here? What is left here? 1 and 0. So 1 is nothing but I. 0 is nothing but j minus 1, right? Now I have top left. Top left. is 0 0, right? So how do I get this 0? I minus 1, j minus 1. So I have I minus 1 matrix of I minus 1 j, which is nothing but top matrix of I j minus 1, which is nothing but left matrix of I minus 1 j minus 1, which is nothing but top left. So I'm just copying it, right, and making it over here. So I need to take, wait a second, I need to take the minimum from this and add it to the matrix only if matrix of ij is equal to 1. If not, it is 0, right? If it is 0, you might say, if it is 0, right, you might say that add, you can add taking from this, and you can take the minimum of 1 comma 1 comma 1, which is 1, and add 1 plus 0 here. It will be 1, and 1 will be added to the answer will be incremented, you might say that. But if you see, are we asked with a 0 submatrix? No. So if it is a 0, it is a negative sign that we doesn't need it actually. So if it is a 0, even this submatrix doesn't count to the answer. And even I have 1 1 1 1 1 1 so on. Let it be, let it be in the matrix, in the original matrix. I am not talking about the matrix which I have changed. So this 0 doesn't count to the answer even for one time, even for itself. I am asked with submatrices, submatrices which are having ones for every cell. Let me take it as every cell. So hello Anshul Tiwari. So hello. Uh, Thanks for attending this live session. So for every cell, I need this once, but I have a 0, so that doesn't count. So only if matrix of ij is equal to 0 and I is greater than 0 and j is less greater than 0, sorry, then matrix ij plus is equal to minimum of matrix I minus 1 j, matrix I j minus 1, matrix I minus 1 j minus 1. Now answer will be incremented with matrix of I j. So this is how we solve this problem and return the answer. This is something like a DP approach. I'll initialize answer is equal to 0. That's what I did here. So here I just skipped is equal to 1 and greater than 0 or greater than 0. Why? Because if I'm saying that I, it clearly indicates that I is true. I is true is nothing but I will be greater than 0. Nothing. Uh, if, like anything but not 0. Right? If I is equal to 2, I is equal to 3, maybe I is equal to 100, it will be true. But if I is equal to 0, no, it won't be true. So that is what I mean when I only write I and when I only write J. Now, you might say that what if I can be 2? Okay, it might be right. So I need something like I and J to be rows and columns. Now, matrix of IJ, I said that I can, this value can be anything but not 0, right? Anything but not 0. So matrix IJ can be 0 or 1. So there is only one probability or one choice that matrix ij will be 1. So the same thing I wrote in the algorithm, I have just wrote the code in this, right? So answer plus is equal to matrix of ij and return answer at the end. And let us see what are the concepts. Sorry, I have forgot about the concepts, right? Array of length is less than or equal to 300. Array of 0 dot length is nothing but, here I said matrix of 0 dot size. matrix dot size. This gives us the number of rows, and this gives number of columns. So answer is equal to 0. I just initialized answer is equal to 0, right? So acceptance rate is 79. It might not be a medium problem. However, if you haven't solved a basic DP problems like unique path sum, and jump game, something like 2D DP problems, then you might feel difficult for it. So this is how you solve this. And so if you have attended live or watching it after the live session, please do subscribe to my channel. And thanks for watching this video. And please do like if you like the explanation, and also share to your friends. Thanks for your support.